Hello guys, today we'll try to understand DAG, that is direct acyclic graph. So what is the DAG? So basic concept we'll understand. Let's go to next slide. If you see in this cube, we have vertices. Okay, let's say for example, this is the point I'm taking. Let's say this is the A, this is B, C, D. This is the E, F, R. If I see right, so these are our vertices. And let's say B to C we are connecting. So this is your edges, right? So I hope you understand what is the vertex and the edges. So let's go to next slide. So in the direct acyclic graph, in this diagram, what we are saying that we have a node or data that is A, then we have direction towards the B, there is another B, and from A2 we can also go to C, A2 also we can go to D, or from D we can go to E. So these are different directed paths. Or we can, if you are going in a city, let's say this is the one of the city 1, city 2, city 3, city 4, city 5. So these are the directed path we are saying. From here we can go to the B point, A to D. But there is no possibility it can come revert back or maybe a single. It's not DAG. C to C travel is not a possibility. It's not creating a kind of circular path. If you are not talking about a circular path and where vertices and edges are pointing right in a linear fashion, so this is your directed acyclic graph. So there are some feature on the DAG. If you think of what is the DAG, DAG's minimum feature, right? So let's say DAG properties. So first we are talking about no direct cycles, no closed loop. If there is a closed loop, then it's not a DAG. It's not a acyclic graph. So we are talking acyclic graph, okay? So that's not a acyclic graph. Second, we are talking about linear order and topological order. So basically what does that mean? So let's say for example, this is A node, B node, C node, previous example. So this can be a possibility. Let's say D. So A to D, right? Or let's say for example, technical term, we are talking U to V. That is a possibility, right? So this is your topological order. Let's say you have the E. So you can travel this way. So topological order is the very important. No vertex itself reach via a non-travel path. So vertex cannot reach. So let's say for example, you are talking here to reach, that is not acceptable. Or here if you are traveling, it is also not acceptable on DAG. So basically what happens, right? Once the C value get calculated, it depends on the B value. This is the value, and based on that we are calculating C value. So that is a possibility on the DAG. I hope you understand what about the DAG.